In the tutorial today I will be talking about how can we improve our CRUD application and see why do we need actually to improve it. So let's start thinking. It will be a little bit more theoretical. Of course I'm gonna show you the code as well. So the last time I mentioned that once we're in the controller action, for example create, and we have the data from the form, what we can do is actually connect each time to the database, create a new connection if we use the native API, which is the oldest version, execute SQL statements, and so on and so forth. So we carry the burden of communication with the database, but this is not what our application is about. Actually, we should be playing with different objects which are entities from the real world, objects and events. They have properties which are characteristics of the real objects. So we have to concentrate on the domain logic, not taking care of technical problems like communicating with the database and all this kind of stuff. How can we do that? Okay, the first approach with the native API, MySQL API for example, has some pros and cons, of course. Set of functions and variables. This is what we have in hand if we decide to use the database API from MySQL. Difficult to replace if we put in the code MySQL connect. After that, if we want to connect to PostgreSQL, we always have to go through the code, and the connection actually can be done only once. But what about the SQL statements? Doing the SQL statements will require actually to go through all our code and change SQL statements with MySQL statements with Postgre or something else. Who knows what? Depends on what our needs are. Okay. We decided we could go the second way. We can use something to abstract the connection to the database and help ourselves easily to create the SQL statements, because escaping of the SQL statements is a big job as well itself. So how can we a little bit abstract the communication with the database and help ourselves? We can do this with database abstraction layer. Database abstraction layer actually it's offering us object-oriented programming approach. We have one object which represents the connection to the database. With this object also we can prepare the statements. Escaping will be done for us. And the last time we saw that such things are, for example, ADOdb, active database objects, PDO, PHP database objects, and of course Zend offers something as well, which is Zend DB adapter. And that's fine. You know that the software looks like onion skins. So we're on the next skin. We're on the next abstraction level. We delegate the communication to the database to an object. That's still improvement compared to the first approach, the native API. We are using objects right now which easily can be replaced. So if we want to connect to another relational database management system, the database abstraction layer can take care of that for us. We create the SQL statements. Is that good or bad? Actually, this is bad. We don't want to create the SQL statements. As I said, we want a fluent object-oriented programming interface. We don't want to deal with details, how the data is saved to the database, how to retrieve the data. We just want to abstract all these details, and we don't want to take care of them. Easy to replace the relational database management system. I already told you that by changing the object. But we still deal with concrete tables. We have to know the name, structure, etc. And we use SQL statements. I also mentioned that. So the second approach is also not very good, and this is how we came to the conclusion that we actually have to use the ORM techniques. Why do we use ORM techniques? This is the main question. Why to make our life a little bit more difficult? Actually, it's not making our lives difficult, it's actually making them a little bit easier. We have to abstract the tables into the database. This is the table data gateway design pattern. If we practice the table data gateway design pattern, if we implement it, this is gonna actually make our life easier, because in this case we don't deal anymore with SQL all the time with this design pattern. We have fetch all, we have insert or update and delete methods, and that's it. We don't have to write all the time SQL statements to retrieve data from the SQL database or to save something. This is another level of abstraction. This is above the database abstraction layer. We can change the tables and still be okay. I mean, if we deal with one object which represents our table, then we can change the name of the table, and this is going to be transparent for our application. Our application knows only about the object which represents the table in the database. It doesn't care actually of the name of the real table. Actually, we do care, but we are one level up right now. In ideal situation, in the ideal world, we could be changing the name of the table and we still will be okay. Okay, this is the table data gateway design pattern. Abstract the tables, objects in the database. Okay, so now we think about objects, but these objects are the objects in the database. We still stick in the world of the technical details. When we do the system analysis, usually we used to build a database. In the database we reflect the objects from the real world, thinking about their characteristics and making them fields in the table. This is how we used to do the design. Okay, our application in this case depends very much on the database. In fact, our application is a servant of the database, because the domain logic is concentrated in the database, and our application actually serves like a shell user interface, in this case to the domain logic. Okay, but we deal with functions which have nothing to do with our domain logic, CRUD functions, and we have to know the structure of the database. This is disadvantage. We still care about the database. In fact, we made our lives easier. We abstracted a little bit, but we are too tight to the database, to the concrete database. We still have to take care about saving, retrieving data from the database, and after that work and get our job done. And our job is to concentrate on the domain logic, on the object, for example, Stoyan, object Cynthia, object John. We have to take care of the technical details still, because we deal with objects which are closer right now to our domain logic, because for example, user table class could represent one table from the database, but in this table we keep many objects, many rows, which represents different objects which we care about. We don't have to actually know about fetching, saving, deleting, editing. All we do care about is to get these objects, get something done, and forget about them. We want to make our life really easy. In the ideal world, actually, we shouldn't be having RAM, which after turning off the computer gets vanished. We should have machines which will keep our objects, our programs, in the RAM. So when we turn on the machine the next time, the program is ready to go. Exactly like we put our laptops in the hibernate mode. So the RAM gets saved in the hard drive, and when you open up again your laptop and you start it again, the operating system is there and your running programs are there. Okay, and this should happen always. Our SSD, our solid state device, actually should become the RAM of our computers, and we are on the right track, I think, but we are not there yet. Okay, so we also don't like very much this approach, and actually what I show you, what I did the last time, is I used exactly this approach. It's okay, it's a good approach, and as you can see, it's understandable for the people, for the programmers. It's easy. Okay, let's look at the code, what we have done the last time. 4 very simple functions which take care about the CRUD: create, retrieve, update, delete. Index is retrieve, and what we did is we have created one object which represents a table from the database. Here we go. We said, okay, object users table, you will be representing the table users, and we are sending the driver as a second parameter, the adapter actually, not the driver. Okay, and that's enough to create such object. Zend made it for us very simple and very easy. Thank you, Zend, for that. Okay, so here we go. This is table data gateway. All you have to do is, you don't have to actually write a code, too much code. You don't have to create the classes. You just instantiate one object from the class ZendDB table gateway. You send as a first parameter the name of the table. The second parameter is the adapter, and that's it. The object will be created for us, and we work very easy after that. We retrieve data with one simple line of code. We say a object table data gateway. In this case I call it with get users table function, but could be called differently. Select. See this method select. Okay, so I retrieve my data, and it's a collection of objects, of array objects. Each row internally, the result set, actually it's a collection of objects. What kind of objects? It's a collection of array objects. These objects allow me to represent the data, to call actually the properties with a standard array interface, or as a properties of one object. Here we go. I'm gonna open that just for the demonstration. Look here. Now both ways is gonna work. So you access the properties exactly as you do for the ordinary array, but also you can call it as a properties of one keys actually of one array, and the properties of one object. Okay, Zend made it really easy for us. The record set has such objects. It could be only arrays as well. Nothing bad with that, but it's better to have this flexibility. Okay, so now we have to take care of saving the object ourselves, of actually creating one new row in the database ourselves. Here we have too many technical details. Look, form is okay, there is almost nothing we can do to improve it. Request, now the form gets the input filters, set the data which comes from the post, which is one array, and after that we check if the form is valid. If it's valid, we get the data we prepared, we unset the data the submit button because we don't need it. If empty data, user registration date, I don't have to do that, but I did it because sometimes I leave this field empty, the date, the registration date. I have to take care of that always. In this example only we have to do it, otherwise the form will take care of filtration and validation of the date, and even better, it could be done on the client side. After that we say this get user table insert data. Okay, we still don't work with our real objects. What is our real object? Our real object is, for example, object Stoyan, object Cynthia, object John. Where these objects are here? We don't see them. We just have to take care of the technical details, saving the data here. And where is our object? No object at all. Okay, this is the disadvantage of this approach. Table data gateway still doesn't allow us to deal only with the domain logic. It requires us to concentrate on the technical details. We don't even care about where our data will be saved, in the database or in the file system or somewhere else. We don't really care to solve our problem. So this is how we come one step further to the idea about the raw data gateway design pattern. Okay, can we do that? When we get the data, we populate one row with this data, and after that deal with this object, which represents in fact one row of our database. We're still not completely satisfied. We still have to deal with technical details. Raw data gateway again doesn't allow us to forget about the database. What it does, this design pattern, is saying, okay, treat each row of the table as a separate object. Okay, we will do that, and we are getting closer to our goal, to abstract the communication with the database or persistent layer, and just think about our domain logic. Okay, right now in our application starts to emerge something which is closer to what actually we care about. It starts to, in this case, we will have right now an object which is closer to our real object. Even though it's a representation, the intention is to represent the row of the table. If the database is properly built, then in database, for each object which we care about, we will have one table, and each row of this table will represent one object of the real world. Okay, so with the table, with the raw data gateway, we are getting closer, we are getting there, even though we are still tied to the database. Raw data gateway, the intention is not to create the object from the real world, but just to represent one row from a table as an object. And this object, right now, as you can see, it's closer to the real objects. Okay, how can we do that? Zend actually helped us a lot. See the third parameter which we can send to the table data gateway. It's called feature. There is one feature which I like very much, and the feature is called raw gateway feature, and all you have to say is which is the ID field. We still deal with the technical details. Who cares about the ID from the tables? But we have to take care of that. So we still have to deal with something which comes from the database, and we have to know the database, but it's getting better. We're getting closer. Okay, so let me show you what I did. I did actually a lot of controllers here, and in this lecture I will be talking about the theory, and the next lecture I will show a little bit more code probably. But let me explain you now. So I call it this way: user row gateway feature controller, because I'm using here row gateway feature. What it does actually, it's forces the table gateway, Zend table data gateway, to return as a result set a collection of row gateway objects, which means now I can take these objects and work with them. I don't have to deal with arrays which represents the different rows. I'm getting close, I'm getting there. Now when I call the data gateway, I will get rows which are represented by objects. I'm getting objects. How that's done? It's extremely easy. We don't have to change our code. As a comparison, I'm gonna show you the pure table data gateway approach and the same approach, but when I want from the database to get the objects which represents each row. Okay, now if you look at the index, of course, the index view script for this controller, for this action, we will see that I'm using, let me find it, of course, look at here. The difference is, oh, I still can use that index, or I haven't changed it yet. In any case, this is not the most important point. The point is that we're dealing with the real objects right now, and I still keep the code even though we switched. Right now we're retrieving from the database objects. Actually, we're retrieving rows which are represented in our application as objects. We still don't have to change anything. It's extremely flexible, but there is a very important difference. Right now we will be getting as a result set a collection of row database objects, row database gateway objects, which is very important. Okay, so let's continue with our thinking a little bit further now. If we get objects, how can we take advantage of that? I still didn't change the code. This controller is just exactly like user controller, and the switch doesn't change anything. I just wanted to show that it's extremely flexible. Now, how can we take advantage of the fact that right now we are getting from the database objects? For each row we are getting one object. Okay, so to see that, actually I have created a controller, user row gateway feature bind controller. What that means? Now let's take advantage of the objects which we are getting. We don't have to deal anymore with populating the form with data. We very easy can save the object, because row data gateway actually defines two methods, save and delete. Okay, let me show you this in code. Now we have to change the default hydrator to object property, because the row data gateway is using public properties to represent each field from the table of the database. Okay, so now service locator, we are just creating a new object of type row gateway from this class. Okay, let me show you in Zend. Zend supplies us right from the box with this class, which allows us to work very easy now. So I'm creating a new instance of class row gateway. I'm giving the IDE, the table, and after that the adapter. So this row gateway object can directly connect to the database. See, now the focus is on the role. The role knows how to save itself and how to delete itself, and also there is a method to find. Here in Zend they didn't implement such thing, but in ADOdb, for example, you can find it. You can find one role by providing the ID of the role. We are here right now in our theoretical thoughts. Abstract the roles. They better represent the real entities of our domain logic. Okay, this is the next onion skin. We go one level up in our way of nirvana, in our way of abstraction. Role data gateway. Now the table data gateway object, instead of simple arrays, returns objects which represent each role. And the most important thing is that these roles are aware about how to save themselves into the database and how to delete or find themselves. In Zend implementation there is no find, so they have to be found differently. Okay, in any case, look at this. Now this object is aware about how to save itself into a table into the database. I'm saying which is the ID of this table, and I'm giving the table name. After that, the adapter, so that this object user now it's ready to save itself. The next good thing, which I like very much, is form bind user. My hydrator is set for the form. So there are two main operations when we talk about communication between two objects, hydration and extraction. Zend provides us with different type of hydrators. So the form actually can be populated very easy if the proper hydrator is set. The default hydrator expects array object, as far as I remember, but we can check that. In any case, to work with role gateway, we have to set a new hydrator, object property. After that, all we have to say is form bind user. When we binding an object like this to the form, four things happens. Right now I'm gonna talk about two of them. If you bind like that an object to a form, if we didn't set the data to the form will be populated with the values of this object. And the second important thing is, after form is valid, the object will be hydrated by the form. This is important for our case. Okay, so let's see if that works right now. I'm gonna copy this long controller name and use it here in my example. See, it still works, no problem. Actually, all of the controllers and view helpers which I have created are working. They just represent different approaches for the communication to the database, and at the end we will come to the highest form, to the outer onion skin, to the highest abstraction level, where we just will deal with classes which represent the real objects or events from our real life. We will be dealing with a network of objects which we will recreate in our application. Okay, instead of dealing with the technical details about the database, we will be working with a virtual database built by objects. Okay, now we're still not there. Okay, let's see now the code. Create action. As you can see, it looks slightly different now. if we have to create an action create in our simple table data gateway, we don't have to create user object. We don't bind to the form because there is nothing to bind to the form. But here, in contrast, you see how we create an object. It's a little bit more code, but it's better. It's abstracting the terms, it's abstracting the code, it's making it better. We'll see how. We are not dealing anymore with so many technical details. Actually, we have to deal a little bit with the technical details, but not so many technical details about the database. Now, when we do create, I'll show you how that looks. Of course, nothing changes on the surface. We're just refactoring and improving the design of the existing code. Martin Fowler, improving the design of existing code, refactoring. It just came to my mind. This book just came to my mind. It's a very good one. So this is what we are doing. Of course, we're not doing it quite well because we should be doing right now test-driven development. We should be creating tests, but this is not the point of this tutorial, actually lesson. I just want to go through all the abstraction levels and explain why we're doing these complex things. Why don't we stop on one level and just forget about the rest? We can get the application working even on the first level when we are using the pure MySQL API functions, which will be deprecated soon or later. Okay, registration date, I have to put this registration, otherwise it's not gonna work. I don't have validators in JavaScript here, so that's why I am entering the date by hand. Go. Oops. Of course. Thank you. That's HTML5. And here we go. We just got one new record. And notice now the communication with the database. We just created one object of type row gateway from this class. We bind now the form to this object, and the saving to the database becomes a little bit easier now, and it's better because it's better abstracted. We again set filters, we cannot avoid that, set data. Maybe one day we will be able to do that, and just concentrate on the domain logic. Now we have to remove the submit button, which is gonna cause errors in with Zend adapter. So we submit this, we remove this submit button, which is again not part of our domain logic. Only the characteristics of the object, our properties of the objects are important. They should be saved in the database. And after that, notice this is the most important thing now. We just say user save. Now the user is one object which is aware how to save itself. We're still not very happy because even though the user knows how to save itself, that's not our business. Actually, as I said, we should concentrate only on the properties and characteristics of the object, not think about how to save it. Save and delete. Let's say object Stoyan. I want to deal with object Stoyan. I care about the name of the object. I care about probably the sex of the object. I care about the age of this entity. But I don't care about save and delete in our business logic. This should be done absolutely transparently for me. How this can be done? I should be dealing only with pure objects which don't have such classes which are technical details, such methods which are technical details. Okay, it made our life a little bit easier. Just as a comparison, I'm gonna show you what I have to do before to save the data. It's done right now only with one line. Before was Data, unset, we did unset, of course, another way as well. Those are technical details. This get user table insert data, and this data is represented as array. I'm not dealing with objects, my domain objects, I'm dealing with arrays, with data. So I stick on the level here, this is disadvantage, where I have to deal with technical details. Here I'm one abstraction level upper. I just say, user, save yourself, and that's it, forget about the rest. The same with the update. I do the same. I just ask the table gateway to return one object with the user ID. I am supplying the user ID, and I'm getting one raw data object which is ready to go. All the properties are set properly, so I just have to say form bind user, and that's it. The form will be populated for me. In this case, I don't know why it didn't populate the form, but I wanted to talk about all these problems, so that's why there is one extra line which will be removed from the repository when I find where the problem is with populating data from the raw data gateway object with our user object. Okay. Deleting also becomes very easy. As I said, this raw gateway object is aware about how to save and how to delete a record from the database. So all I have to do, and I left the line before here just a comparison, I have to do two things here. I have to get the user from the database exactly the same way I did for the update, and after that I have to order this object to delete itself. Yes, it could be done this way, and it's simpler, but as I said, theoretically dealing with objects is better than dealing with technical details about the database. Okay, let's look at my mind map and see what else can we do. Now, add domain logic to these raw objects. Think for them as domain objects. Okay, these objects are fine, but they still are tied to the rows of the database. I'm not free actually to use this objects to do the domain logic. Let's say I want the object Stoyan to say hello or greet everybody with his name. Say, okay, hello from Stoyan, I'm Stoyan, my name is Stoyan. How can I do that? I still have to take care of that. So if I create my custom object, one custom object with the properties which will get populated from the database, and I add a domain logic at this level on this object, then this design pattern is called active record. Let me see that. Add domain logic to these raw objects. Think for them as domain objects. For example, teach object user to tell his name, and this is done through defining a method. Add tell your name method, for example. This method will take the property which is called my name or name, user name, for example, and can say my name is Stoyan. Okay, so we'll still think about technical details. We're not detached from the concrete implementation, because we still carry with us the methods like save, delete, and eventually find. Zend doesn't give us an easy out-of-the-box solution for that, but it gives us, of course, a solution, and we will see this solution just in a second. We still have to think about this object should save itself. This object should carry the logic of saving itself to the database or deleting itself into the database. Okay, can we go one step further, even further? Yes, we can, and Zend gives us a chance to do that with table data gateway object. Result set prototype. By setting the fourth parameter. If we send a fourth parameter, this could be a prototype of an object which will be cloned and returned by the result set. Is gonna become the result set is gonna become one collection of such objects, and I'm absolutely free now to do whatever I like. I can create one object which suits me perfectly. Of course, I still have to take care about how these objects will be saved into the database. Am I going to delegate the saving to this object, or am I going to create something else? And this is how we come to the conclusion that probably we could create so-called data mapper, another object which will deal with my domain objects. So domain objects get hydrated and returned to me by the record set, but they may not know how to save themselves back to the database. So I have to create another object called data mapper, which is gonna save this object to the database. This could be done, and in the Acrobats example, the famous album application, tutorial application, he is doing exactly that. Album table plays the role of the table gateway and the data mapper, because this data mapper saves the album application. I'm not gonna show this right now in this tutorial. As I said, it's gonna be more theoretical, but I'm gonna show you the approach. Okay, so we are one level up. Forget about the database. We cannot completely forget about the database, because right now we have to create an object which is called data mapper, but we can create freely objects, and I'm gonna show you that, which will be returned as a result set. And here it is, the object. This is how the object looks like, one of the possible objects. Here, when I create now the objects, the class, and after that from this class the object will be instantiated, I think only and purely about my domain logic. What do I want to save in the database? In this case, I'm still not detached from the database. I still have to take care about each one of the fields. But as you can see, I keep only what is necessary for this object to be hydrated and the data to be extracted of it from this object. But that's it, nothing more. I don't think about how this object is going to be saved right now in this class, in this particular class. Another class will take care, another object will take care of saving this to the database. And that's why I need two technical details here, two methods which allow me to hydrate this object and extract the data from the object. As you can see, the properties which represents the characteristics of the real objects are public, so they are accessible. Okay, how this can be done? This is done very easy with Zend, again with our simple CRUD which I have created. Look, it's very simple. All you have to do is just provide with the fourth parameters. Of course, as a third one you have to say null, because I don't want right now the raw gateway objects to be returned in the result set. I want my user object to be returned. What I do is I create a prototype object, one instance of result set, and after that, as a parameter, set array object prototype. I'm setting the user, the object which I want to be hydrated and returned from the database, from my table data gateway. Here I put it the comments. So now I have to change the hydrator for the form. Actually, in this case I don't even have to change the hydrator because my object is array object. It doesn't implement the interface, but still has two methods which will be required by Zend form. Let me show you this object again. Here we go. Okay, I have exchange array and get array copy. If I'm gonna use if I have defined these methods, I don't have to change the default hydrator of the form. And also this object will be hydrated when I retrieve data from the database. Okay. And as the last example, I have done something else. Now the object user, which I just showed it to you, doesn't follow the very good practices of the object-oriented programming. These properties should be private or protected, and I have to have accessory methods for each one of them. In other words, I have to have setters and getters for each one of them. So that's why I have created another object which follows the rules of the object-oriented best practices. And here we go. I have created the object, as you can see, and that's it. This is purely created model of the real world, one user. I'm quite abstract now. I don't have to deal with database. I still deal with the database, but not at the level of the object, as you can see. I can change these properties because they're not accessible. I still can keep them as I have them in the database, but it's not mandatory. I can change them because I have accessory methods. Set user ID, get user ID, and so on and so forth. Okay, and this is this example. User hydration result set controller. This is how you do that. Notice the difference. The difference is only here in the function get users table, in the method gets users table. All I have to do is, instead of the original hydrator, when I prepare the result set property prototype, I'm using a different class and I'm providing with two parameters. One is the reflection hydrator, different hydrator, and I again have to give, of course, one instance of my class which gets cloned internally when I call Zend table data gateway, and the results set should be returned. So my prototype will be cloned, hydrated, and returned into the result set, which is just brilliant. Now I'm quite abstract, but Zend don't have a tool like Doctrine, for example. Right now I'm tempted to do something like this. As I said, we are on the right track. We abstract ourselves from the technical details. We can think not about the database, and we don't have to build a database first. Right now we can build the domain logic by creating the classes, and after that from these classes we will instantiate objects which will be populated with data, which will be hydrated with data to reflect the different real objects. And I don't have to think about the database. Still, with Zend, if I use the pure Zend tools, I have to take care of saving these objects to the database, but I'm quite abstract, and here As I said, I'm tempted to have Entity Manager as Doctrine does. This project is different from Zend Framework 2. It's a brilliant project which allows me to abstract myself even one level up. I don't have to think anymore about the database, and I don't have to care about how these objects will be saved to the database. I don't have to create and practice data mapper design pattern myself. Everything is done for me with the doctrine, and this is the last level of abstraction. I think about objects, I create them, I think about the objects in my domain logic, I create them as entities, and I just have to think about their instantiation. But the entity manager, which comes with doctrine 2, saves them to the database. It also retrieves these objects from the database. It's just a brilliant tool. But with Zend we cannot do that. We have to combine Zend with doctrine 2. Otherwise we will stick on this level. Forget about the database, but create a domain module using entities, network of objects, virtual database, data mapper. We have to use a data mapper now. Persisting is not a concern for this object anymore. We don't need methods like save, delete, etc. We have only the properties characteristics of the object and accessory methods to set and get values to the properties. We came to this point, but with Zend we have to take care about saving these objects to the database and retrieving them from the database ourselves. Zend has these tools, but they're not such evolved like the tools of doctrine. This is why we came through all these troubles creating different objects and classes, putting them into the models. In the perfect world, we will not need to save anything to persistent layer. The SSD, solid state device, I told you already that. Drives will become the random access memory of the computer. Even if you turn your computer off, the running programs will keep their state until we decide to exit or close the program. Okay. So the last level, the seventh level, seventh heaven, actually is forget about the database, but delegate the saving and retrieval of the objects to something else, to somebody else. Data mapper like doctrine. We don't have to create the data mapper objects anymore for each table, because right now in the Acrobats tutorial application he has created user table, which is exactly the data mapper. It plays the role of the data mapper partially and saves the object album to the database. What did I say? User table? No, album table. Okay, so album table, the purpose of this table, this class is actually to play the role of the table, data gateway and data mapper. There is doctrine entity manager, so we don't have to create such thing. As I mentioned, album table or in our application user table. Network of objects, virtual database. This is the highest level of abstraction which we can reach. Okay, and I show it to you how can we do that. This is our highest level we reached, but here in the application you'll see that I haven't finished yet. Probably in a separate lection, in a separate tutorial, I'm gonna concentrate more on the code and show how that's done directly. It's very easy, it becomes quite easy. I'm not gonna change this code, so the code is ready. Here we go with my comments. As I previously showed, I have one user entity. I call it entity by purpose. It's into the folder entity. Let me show you this. User entity. And in user entity, I really forgot about the database. I just built one object. I was concentrating on thinking about my object. I'm still not detached completely from the database, so that's why I keep in the back of my head how the fields are called in the table. So that's why I'm using these variable names, underscore, lowercase underscore. But eventually I will be detached when I start using doctrine. Right now we're not there yet. I have to explain doctrine in another lection, and after that we'll continue with doctrine. But as you can see, that's it. I don't have any other logic, not even filters. I don't think filters we should put here, and validators maybe for very simple and use cases, yes, but in general no. The entity should be pure and should deal purely only with the characteristics of the real object, accessory methods, and that's it. And Zend allows us to deal with such objects. Here we go. We instantiate one object and send it as parameter as a prototype to hydrating result set. We say what type of hydrator should be used for this object. In this case is a reflection hydrator, could be used probably class methods hydrator, but with reflection hydrator I think it works. I haven't tried. And after that we send the result set prototype to our user data gateway. So the user gateway, user table data gateway takes the row from the database, hydrates our object, which is user entity, and returns this object to us. Now we easily can work and concentrate on the domain logic. In the next lection where I'm gonna show the doctrine, I'm gonna introduce doctrine, we'll see that we don't have to do anything, just create our entities, instantiate doctrine entity manager, and start working. We don't even have to do that. And create the CRUD by creating 4 different methods, and that's it. Dealing with the database, all the operations with the database will be taken care by doctrine. In the ideal world, as I said, I would imagine that we will not need even such tool like doctrine, but we're not there yet. Okay, so those are the 7 level of abstraction, and here in the mind map I'm trying to represent the different objects. So I can use the table data gateway, the Zend table data gateway. The simplest way is just to get one array of arrays, if you want to think of them like that. In fact, we had the result set, which is Zend DB result set object, and we have array objects. Each row is an array object. This is the simplest use. When we supply only with the name of the table, let me go there, only with the name of the table and the adapter. This is what the table data gateway, Zend table data gateway, can do for us. And we stop there. We don't need to go to another level of abstractions. If we want to go further, what we can do is we can use a feature as a third parameter to table data gateway. As a third parameter, if we say row gateway feature, the row set will be returned. The row set will contain object of type Zend row data gateway. And as you can see, these objects can save themselves. They are more intelligent. They can save themselves into the database, or they can delete them themselves. Okay, the result set is ZendDB result set each row is an ZendDB row gateway, row gateway. Zend table gateway feature, row gateway feature. This is just to remind me that this is what I have to supply as a third parameter to table data gateway to get my row gateway objects. Okay. And those are standard things which are coming out of the box, so you don't have to do anything. You can stop on this level of abstraction by just by using the out of the box components of Zend and subcomponents of Zend. You don't have to create your own classes, you don't have to do anything. If you want to stop on this level of abstraction, that's okay. But if you want to go further, actually, and you want to start creating one network of objects in your application, if you want to stick and think about your domain logic, then you can start creating your domain logic, domain model. This actually it's a design pattern. It's architectural design pattern, domain model. If you want to practice this design pattern, then you can create a network of objects, thinking only about them. And Zend, out of the box, can take care of that as well. It takes this object instances of these classes, which represents the real world objects and events. It takes them as a prototypes, and the result set actually returns our objects. But in this case, we have to take care about saving them into the database. This is what we have to do ourselves. And what Rob Allen, Acrobat has shown us in his tutorial application is this approach. He showed us that we can create something like a data mapper, one object which takes care of saving one object of type album, in his case, into the table album. But this object, which is called data mapper, which plays the role of the data mapper, we have created ourselves, and it helps us to save particular objects to a particular table in the database. So he saves only objects of type album to the table album, and it's called album table. In my case, I have created such object. Let me show you. It's called users table. This is my data mapper, which takes care of saving only the objects of class user to the database. So this object, user, could be returned in the result set, but after that, when I want to save it to the database, I have to use my users table object. So user table object, in order to be saved to the database, have to be saved with users table. This is my data mapper. And as I said, I haven't shown that, but the highest level of abstraction is when we integrate Doctrine 2 in our Zend framework application. In this case, we use Doctrine Entity Manager. Or thank you for watching this. Hopefully it was helpful to someone, and see you the next time.